Hello everyone, welcome to the Code. And in this part, I'm going to teach you about the background processes in FastAPI application. So let's think about your application have some kind of critical task or the task which consumes too much of time. Those things need to be handled with the background process, not with the asynchronous APIs. But how we can differentiate that which task will go into the asynchronous API because I created these asynchronous API just to handle multiple requests from the user. So in this part, I'm going to clarify all those things. And without any delay, let's see what I'm going to teach you in this part. I'm going to give you a very practical example so that you can understand that why these background processes are required. So first of all, what I will do, I will give you a very simple difference between the asynchronous API and background process. It's a very simple representation and you will understand why we need it. Okay, it's the second thing. Before developing this background process, we need to understand few things and those few things will be covered in this part. The third thing is we are going to do some basic level of implementation of background processes so that we can understand that how fast API do these kind of work. Okay, so once these all things are completed, then we will go some heavy task, that is production level implementation. And when this production level implementation comes, the first thing which we need to do is we need to understand the flow. Okay, so once we understand the flow, understood the flow, then we will go and create the setup for us. So in a production setup, we are going to need much more components that from the setup we already have. Like we need this Redis, we need this Celery. So we are going to do this in Docker, and we are going to use that uh, running services into our fast API application. So once these applications are running inside the Docker, then we will take them and integrate with our fast API. I'm going to do this, and also I will just do the testing with the Postman so that you can see what is the request response and why we did this. So first of all, in the production level implementation, we are going to use the example of e-commerce application. Just you all use this e-commerce application where you place the order, and after placing the order, when you go to your orders tab, there you will see that your order is going to be shipped, your order is going to be packaged, and your order is going to be delivered. This task is very complex, and it takes time of days, hours, and might be weeks. But this process is continuously running in your application, and whenever you go to your application, you will see that where my order is currently present. So that particular thing is running inside the background process. I guess you are getting some idea like what I'm trying to say with the background process, why we need it. So we are going to implement this simple implementation in a fast API application. So before that, let's start with the point number one, where I'm going to demonstrate you like what is the difference between the asynchronous API and background process. Okay, so for that, what I will do, I just created a very simple HTML page. So inside this HTML page, I have these two tabs, this asynchronous API endpoint and background job. What these two tabs do, when I click on this run simulation, it will show you the actual what is happening behind the scene, like when the request go, when the response come to the user. So for that, what I want from you all is, okay, let me just open some draw tools so that I can clearly show. Okay, so here it is. I just want all of you to focus in these two parts. The first part is this, and the second part is this. Okay. So we right now we know like where we need to focus. So first of all, what I will do, I will just run the simulation of the asynchronous API. Okay, let me just minimize it from where. Okay. So when I run the simulation, what is happening right now? The client and the server. Server is processing your request. If you see, okay, I'll run it again. So when I execute this run simulation, the server request received, okay, connection is open, it is running some process. And when the server completed the request, it will send back the response to the user. Okay, it's a normal behavior and there are some wait because it is doing some kind of process. That's why it took some 2 to 3 seconds to process it. let's come back to the background job. So when we run this background job, what happens? So immediately it gives you back the response. Okay, your application request accepted successfully. We accepted your request successfully, and we are doing some work on it. It just sent back the response. Okay, your request is accepted, and we are doing some work. Okay, let me run it again so that we can clearly see. And if you see this part, after getting this response you will show in your web application, and this is the part which you will trace it from your log. You can do some kind of mechanism where you are storing these particular status like task completed or some status change to your database. So from that database, you can directly fetch the completed status, sorry, the complete status or running status, whatever the thing is there which is running at the backend. So this is the thing which this background job will provide to us. This background job will provide us the response immediately by saying, okay, I accepted your request and I will do the process. But in the asynchronous API endpoint, what it will do, it will hold the complete transaction until the response is not created. With the async API, you are free to hit that API multiple times. It will not block you. But again, all those APIs requests will take time to generate the response if there is some time consuming work is there. In the background job, what it will do, it will immediately send you back the response and it will say, okay, I'm doing some process and let me handle it. You can do some other work as well. So in the background job also, you will get the functionality to hit the particular request API multiple times, but it will not hold you back to wait for that particular response. Okay, so this is the simple implementation, like why this async API endpoint is present and why this background job is present. Okay, so right now we understood one thing, what is this async API endpoint and what this background job is. So now coming back to the second point where I'm going to teach you the some basic stuff before development of the background jobs. Okay, so for that, what I will do, I will just open my paint and I will just do some sketching here. Okay, so here it is. Let's see. Okay, so here is one box and here is one another box. So in this box, what is there is asynchronous API, async API. And here we have this background job. So what this asynchronous API will do is when you hit your request to fast API application, it will there are multiple threads which are running at the backends in your fast API application. So when you hit your request to this fast API application, what it will do, it will initiate a thread. It is a thread, and it will place this request API into this thread. Again, when you hit this, and it will do some kind of process. Let's say that particular process is taking some time, and let's say for 10 seconds, and the user want to hit that same API again. So what it will do, it will add another API request in the same thread. So in this way, what it will do, it will add the same API again, 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 and again. These all will process simultaneously, but they all will take time, as it might be possible, like some take 5 seconds, some take time 10 seconds, and they will send back the response when they are completed. Coming to this background job, what it will do, you send the request, okay, to your fast API application. Fast API application is running in subthread. When it get the background job, what it will do, it will initiate another thread for the background job. In the another thread of this background job, you will send all the request inside the background job, and it will stack those requests. Once those requests are stacked, it will process one by one. So once your job is completed, it will send back the response to your DB or some other fetch API. Let's say you have some API implemented in your web application, which is fetching some kind of API in a cycle of every 5 seconds. So let's say this particular job is completed, so it will send back the response to that particular database, and that database will provide the data to your fetch API. Okay, so in this way, this background job will work. As I said, this async API will work simultaneously on all these requests. But in this background job, everything will go in a stack. It means we are going to implement some kind of synchronous behavior in it. And with the name in this asynchronous API, this fast API, like where we provide this async def and that API name, like API method name. So it is already in asynchronous behavior. Asynchronous behavior. So these background jobs will always be in synchronous behavior, and these async API, as their description told, these all are in asynchronous in behavior. So when we do or when we create these background jobs, we need to take care that we should not provide this async def while creating the method. We should not use it. We should just simply put def and the method name. Okay. So wherever we are going to create the background job to some API or some API method, we should not use the async or await. We are going to use only the def. Now let's come to the third part where I'm going to do the basic level of implementation of background process. So for that, what I will do, I already have this repo where I'm developing this e-commerce website using the Fast API background. And here, what I will do, I will share this repo. It is open to all in the description. You can go and clone it and do as you like. What I will do, I will just create a very one simple API to demonstrate like how this background process can be integrated into the Fast API very easily. So here, what I have is I already have this uh, code cloned into my repo. And what I will do, I will just go simply into my API section, and I'll create new file. Let's say basic background, background, basic background.py. Okay. So here I have this basic background.py, and what I will do, I just simply import the from Fast API import background task. Okay, I have this one, and I'm going to just mimic a very simple task. So I will just import time, nothing else. Okay, so I have this import time. What I will do, I will create two methods. First, this write log. Okay, in the write log, okay, let me just do this printing. Let me do some logger statement here as well. So what I will do, I will just uh, let's say mm, background task messages, and inside the messages will go. Okay, that's fine. Where did I just put another extra bracket here? Okay. Mm, okay, I just need to do this. Okay, fine. So I have this thing, and what I will do, I'm just going to mimic this background process, which is taking some time. So for that, what I will do, I will just put this time dot sleep here with the 5 second. Okay, let's not do the 10 seconds. Let's do the 5 second. Okay, so I have this write log mechanism where it will do the task and it will take some 5 seconds of time. Okay, and after this, I will do the again. What I will do, this background task completed. Completed writing to the log. Okay. So I have created one method. As I said, it should be synchronous. So that's why we are not using any kind of async here. And here, what I will do just send notification. Okay, send notification. And inside the send notification, okay, I will take the email, print sending notification to email. Okay, fine, 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 fine. But it is not a thing which we are going to do. We are going to use the background task here. So what I will do, okay, background tasks dot add task. Okay, inside the add task, I will do the write log. Okay, it is the write log sending notification to this email with message this. Okay, fine. And let's, okay, I guess it is fine. Let's hard code the message here. We are not going to do very much of hard work here. Okay, so what I will do, I will just put the message with message, hey, it's completed. Okay, hey, it's completed. Okay, fine. So I just put it here, and what I will do, I will do the return message notification will be sent in the background. Okay, I need to create this as an API. So what I will do, I need to create the router also here. So what I will do, I will just copy this router. I will add it here. Okay, router. And I need to extract this router also, this API router. It will come from the FastAPI. So what I will do, API router. Okay, so I just call the router, and here I need to add this at the rate router dot post send notification to this particular email. Okay, so here what I will do here, and it will take the argument of this. It is very simple. So here I just created one very simple API with the background task. What I did is, all I have to do, whatever the thing which I'm trying to run from the background or which is taking some time from the application, I'm adding that particular task into add task. After using this add task, I'm calling the method in which I'm doing the process, and also after doing it, whatever the argument it needed, I'm passing it here. It's simple. So you got the input from the user using request, and that particular input will go inside this method, and this method will do all the process, and it will revert you back with the response. So here, as we have this time dot sleep of 5 seconds, so it will take some of time, and then it will do the logging as well. Okay, so here it is completed. Now what I need to do is, I just need to go to my main.py. Okay, and what I need to do, I just need to call this, okay, basic background. Okay, so it's a basic background. I called it here. Let's add it into the app dot include router basic background. Okay, API v1 background task. So why I'm doing this, like why I'm using the router and why I'm calling that here. So I just want to segregate all the APIs. I do not want to mix everything into a single file. So I created a router for each of my API application, and all of those API applications are called inside my main.py, where I just provided everything into a very simple way, so that whenever if any one thing need to be updated, all the other things will be independent. Great. So I have these all the things. Now what we need to do is we need to just run our application and to see whether it will work or not. So first of all, what we will do, we need to just start our env, the virtual environment. So I guess it is one directory behind. Okay, let me do the env. Okay, so nothing is here. Python -m env env. Okay. So it will initiate one virtual environment. We should be very careful when we are using this Python dependencies because we do not want anything to store inside our system, which where we are developing. We want everything in a document. Okay, so we have it. Let's do the source env script activate. Okay, so we just activated it. Let's go inside of it. Fast API e-commerce. Let's do the ls and we will pip install -r requirement.txt. So what I will do, I will just skip all the requirement collection. Okay, I guess it might take not much time. All the dependencies are already present. Okay, I'm just going to fast forward it. Okay, so we have all the things present inside our virtual environment to run our application. Now uh, let's do the other thing, but before that, we also implemented some security in our application. So for that, what I need to do is I need to provide some secret key inside my env, and that env is called inside my config.py. Without this env, it will not work. Without this secret key, it will not work. So the secret key should be generated. So what I will do, I will just generate one secret key. Okay. So what I will do, I will do the Python. Okay. Import secrets. Okay. Then what I will do, just secrets dot URL safe token dot okay token underscore URL safe and then 16 okay fine 16 bit. It should generate one token. Okay, it generated one token and I'm going to put that here. This token is present right now. Okay, now I can easily start my application. So these are all the security measures which we integrated in our previous lectures. Uh, if you are not familiar, don't worry. In the last part, when we are going to implement the Docker file to set up our complete project, I will explain it in detail and again. Okay, so we have all the things. Let's start our server. Okay, where is the command? Uvcon main app reload. Okay, it should start the server. Okay, cannot import name background from API. Where it is failing in main.py from API. Okay. What I did wrong. Okay, background, basic background from API import basic background. Okay, I just took the wrong name here. Okay, let me recorrect it. Where is the rename? Where is the rename? Mm, Rename, copy file, share, Maven, copy file, run debug. Okay, it is here. Okay, background.py basic. The spelling of basic was wrong. Okay, now it is fine. Let's check it here again. Okay, our application is running fine. So let's open our Postman so that we can execute this API and test like what is happening here. Okay, just let me close this part. It is not required. This SEMrush, close window. Okay, fine. Yes, dismiss. Okay, so here we have this application running at 8000 port. Okay, that's fine. And what API we have? We have this API v1 background. Let me copy it from here. API v1 background, API v1 background. And what we need from the URL, let's go back here and we need this send notification and then email. Okay, so I will add it here, send notification and then email. Let's email just abc@gmail.com. Okay, So we do not need any kind of body here. We can simply just run this post request so that we can understand whether it is working fine or not. So I will remove all the things and I will just simply put the send button here. Okay, I'm getting this internal server error. Why is so? Super type object is not instance subtype. um, okay, my bad. What I did was wrong. Okay, so here what I did is like I imported the background task, which is a class, and I used directly this class, which I should not. I need to create an object for it. So what I need to do is I need to create one object. So background task will be of type this background task, and this background task will be used here. Okay, so this background task dot add task, and I guess it should work fine now. Okay, let me refresh it again. Okay, so it is running fine. Let me do the send. Okay, message. The notification will be sent in the background. I got the response immediately, even though I created one method which have some 5 seconds of wait. Let's go to our UV count. So here what I'm doing is this send notification. Okay, hey, it's completed. Completing writing to the log. So these all things just completed, but after some time. So just to do that again, what I will do, I will just go and change the message. Okay, so it's it's too long. Okay, I guess that will do the work. I just saved it and I will hit the API again. Okay, let's go back here and we will see here what is coming right now. Okay, completing writing the log, completed writing the log, and it's too long. So it did a work which was intended and it took some time, but the response which the user got was immediate. So user do not have to wait. You can do some kind of loading mechanism inside your web application where you can show to the user, okay, this particular thing is running and we will provide you the data once it is available. But here you can definitely see this particular message that, okay, all the inputs which the user gave was validated and they are correct to do the further process so that I can reassure the user, okay, your request is accepted and we are working on it. Okay, so this thing is complete. It was very simple. What we had to do is just simply created one API with the background task. We use the object and using the object, I just did the add task. Inside the add task, I called the method which will going to do the process. But you need to be very careful because you do not want to put a heavy load in these kind of threads where your fast API applications are running. All the heavy tasks should be worked on independently on some different server or on some different namespace. Namespace is just something different, like where your application is running. It should not hamper the performance of your application. It should not slow down your application. So that's why we need these background jobs to be worked on some different server or on some different plane. So this is for just some simple task you can do, but for heavy tasks you should not. And for that only, let me go back to our slide. Okay, so for that only, we are going to work on this production level implementation example for the e-commerce application. So what we are going to develop here, we are going to develop a mechanism or API. Let's say you are using this Amazon e-commerce application and you placed a order. After placing the order, what happened is in the orders tab, you will see your order is completed, not complete, not completed. Your order placed successfully, but in a below tab, you will see the order start processing. After order start processing, uh, you will see after a few hours or after 1 or 2 days, you will see your order is shipped. Then after a few hours or after a few days, you will see your order is arriving, and when that particular order is arrived, that particular tab will show order delivered successfully. So these things are happening in the background. You do not need to provide any kind of input to know the details. And that's the thing which we are going to implement in our Fast API application. So it is just one example like how we are going to do it. The main setup which we are going to develop here will be the same for all your purpose or for your all analytic processes or some other processes, but the logic will be the same. So we are going to use this particular logic, use particular setup to demonstrate you. Okay. So first of all, what we need to do is we need to understand the flow. We need to understand like what are the components are doing and why we need those. That's why, then why, sorry, then we can going to develop that. Okay. So what I will do, I will come back here, and what I will do, I'll just do the new painting. Okay, don't save. Fine. So in this setup, what we need is, okay, so here is the user, and user is sending the request to your, let's say, app. It is the app. This app is using some fast API application application APIs. Your fast API backend APIs is used by this app. So when this app send a request, your fast API application will filter out light task and heavy task. What I mean by light task and heavy task are those which will take time to execute, as I show, as I demonstrate the example of your order delivery. Okay, so once you have this heavy task, what it will do, it will send it to Celery. It is one server, this Celery. What this Celery will do, Celery will push it to the Redis queue. Redis queue. Redis queue, it's like a table where all the things come from here, and there is this Celery worker. What this Celery worker will do, this Celery worker will watch this particular tab. So all the orders which are coming here will go to the last block. And this Celery worker is waiting for that task to be present at this block. So whenever a task will come, a task will go from here and it will go to the last block where the Celery worker is watching. It is the complete Redis queue. When the Celery worker will find that particular task, it will going to execute it. Okay, execute the task. So right now, this Celery worker is executing the task. When the task is completed, what it will do, it will send the response to your DB, to your DB, or you can set up your Redis server or Redis queue, the same one which we have here, to collect the responses. But I will prefer the DB. So here you have the DB where you are going to store the exec execution status. Once the status is available at this DB, inside your app, there is one another fetching API. This fetching API will fetch the data as per your calculation. Let's say your task, let's say your task, sometimes it take 1 hour, or sometimes it take days. So what you do is you take this fetching API and you just push it in every 1 hour with the scheduled job. So this fetch API will connect to this DB and look out for that particular field. Once it get the data to this fast API application, it will send back the response to the application which this particular user is using. Okay, so we understood this Celery and this Redis, why we need it. The Celery is the one which will take the uh, task, place it to the Redis queue. Then there is one Celery worker. The Celery worker will watch this Redis queue so promptly. Whenever a task will come, it will take that task, and it will start executing it. Once this execution is completed, it will send the response or it will send the data to your DB. And then from some different API which you created, you will fetch that data and send it back to the user without even their request. Okay, so we understood the flow, and this is what we are going to develop. To set up this Celery and Redis for our fast API application, there is a one roadmap. So let's see what it is. So for it, okay, let me just share it like this. Okay, so first of all, what we need to do is we will up the Redis server from Docker container by exposing the port 6379 so that we can use the local host colon 6379 in our fast API application. Okay, so it's the first step. Second thing is we need to set up the Celery app in fast API. We are not going to directly spin the Celery container and then integrate into our fast API. No, it will not work like this. This Celery app is going to use the logic which is present in our fast API application. So this application will be mounted into this Celery app container. Okay, so this is the two thing. So first of all, we just executed the Redis server that is independent. Second thing, we need to work on the Celery app. So for that, we are going to set up the Celery app in the fast API. Then we create the synchronous Celery task process. As I told you, the background process will be synchronous. So we are going to create one process, one method, one logic, which will be synchronous in nature and will do the process for us for the API, which will do the background, which will create the background jobs. Okay. So once the logic is created, then we are going to create the API. That API will use the logic of that particular synchronous logic. But we can create this API asynchronous. The API will be asynchronous, but the logic will be the synchronous. Okay, fine. After doing these all the things, we are going to integrate it with the fast API main.py. So everything is fine. We are going to create a separate router for this Celery task, and that Celery task will be integrated with our main app, the fast API main app, and then we will test it. So before testing, obviously, we need to start the Celery container inside the Docker. So we just developed all the things. Now it's time to mount the Celery app into a Docker container and to execute that Docker container. Once this Docker container service is up and running, our server fast API is up and running, then the last thing is only pending, which is the testing the code. So it is the roadmap. So now let's come back here. To set up the Celery into our application, first of all, what we need is, as we have discussed, like we are going to create one mechanism for the order delivery in which there will be three status: this packaging, shipping, and delivered. So to do that, we are going to create everything as a production level. So we are going to integrate it with our existing database. So for the existing database, in the previous lectures, we use this db.py and this config.py. Inside this config.py, I provided the database URL. This database URL is something of uh, the it is something specific syntax. It is the PostgreSQL, the particular database which I'm using. It is the async pg. It is the asynchronous database driver. It is this Postgres is the username. This root is the password. The local host is this server where my Postgres is running. This 5432 is the port which I exposed to access this service. And this FastAPI ecom is my database name. Okay, so it is a complete setup and this database is also working. So let's go directly to our models.py. First, what we will do to process all the things, we are going to create one table. We are going to create one independent table so that we can analyze this particular logic more clearly and with more easy way. So what I will do, okay, let me just come here. Okay, so here I have, and what I will do, I'll just create one model. Okay, so here's the model, this class order. It is a very basic model. Here I have four fields. One is ID, it is the primary index. It will increment sequentially. It is the customer name, the customer who is placing the order. It is the item for which the customer is placing the order, and the status. Initially, what we want is when the customer is placing the order should be when the customer is placing the order, that there should be some message like your order is placed, but it is not delivered to the customer. So that particular thing will be changed in the time. Okay, so I have this one, and what I will do as I'm using the SQL model. So obviously I'm going to use the Alembic for it. And to work with the Alembic, what I will do, I will come here and I'll just do the Alembic revision. Let me just save it again so that it will reflect here. Okay, coming to here, and I will update it to the create order table. So I just created a revision in the on the current revision. I'm just I did the change, and that particular change I'm going to migrate to my database table. So what I did is I just put Alembic revision auto generate -m the particular message whatever you want to create. Okay, so I will just run this command. Okay, it will do all the changes which need to be necessary. And to push these changes to our database, what I need to do is Alembic upgrade head. So let me run this Alembic upgrade head. Okay, the SQL model is not defined. That is fine. So for that, what I need to do is I need to go inside the Alembic, inside the versions. After the version, okay, I need to this create order table. It is the latest one. And here I can see the SQL model is missing from the import. Okay, that's fine. There is no issue. What we will do, we will do directly import SQL model. Okay, I guess that will do the work. Let's come back here and do the Alembic upgrade head again. So when we did the Alembic upgrade head again, okay, it executed successfully. Let's check our database whether the table is created or not. Okay, I can see here. Let me just refresh it. Okay, this order table is here right now. Let me just refresh it, this particular database. Okay, this order table is here. It is freshly created. Fine. The one task is done. We created the SQL model, and now it's time to work on the logic part. Okay, so what we will do, I will just minimize all the things which are not required from the project structure. And here I will create new file that will be called the worker.py. Okay, will be the worker.py. Okay, I already have this worker.py. Fine. Okay, so inside this worker.py, what I have is I'm just initiating the Celery app. So let's go back here to our slideshow. And first of all, we need to set up the Celery app in FastAPI. So we created the Celery app inside the FastAPI. It is the Celery. I just simply import the Celery and I created one instance of the Celery. What is this worker, this broker, and backend? This worker is nothing, just the name of your app, Celery app. It can be anything. It can be my app. It can be Celery app. I just provided the worker here. Okay, it is fine. This is a worker. What is the broker? As we understood in the previous explanation, where we discussed about the system design of this Celery and Redis, the Celery is the one who will pick the task from the Redis message queue. So what it will do, first of all, this Celery will check for this broker, which is Redis, for the task. And from the backend, when the task is completed, it want to push the response back to the broker. So it will take the request, it will take the task from the broker, and then once it is completed, it will send back the response to the backend. Okay, so this part is also clear. Now let's come to the tasks.py. So inside the tasks.py, what we're gonna do is we are going to do some modification here. We are not going to use the get session. Why we are not going to use the get session? As I told you, this process order will be the synchronous logic, and this particular get session from the core.db, let me take you there. Why I'm doing like why I am explaining this, because I do not want you to repeat the same mistake which I did earlier in my work. So what I did earlier was like I just imported the asynchronous session, which was a utility for me, and I just imported this asynchronous session from this db.py to my where is that task.py, and I created the session from it, and it just created a mess for me. It was a really bad mess. So I do not want you to repeat this particular issue. Okay, so for that, what we are going to do is we are going to create one other get synchronous session. Okay, so we are going to create one get sync session. Okay, after this, we are going to provide with session. mm, we are going to need some engine. That engine will be mm, mm, from SQL from SQL Alchemy dot orm. Oh, what happened? From SQL Alchemy import from SQL Alchemy import create engine. Okay, okay. After this, what I need to do is I need to create the engine for it. Okay, engine equals to create engine, and inside the create engine, what I need is the okay, I need to import the from settings from core dot config import settings. Okay, and from the settings I need to provide here is settings dot database URL. Echo true, it is not required. I do not want to replace anything. Okay, so it is the engine. This engine will go inside the session, and from the session, mm, okay, as session, yield session. Okay, fine. So I got this synchronous session for it, and I will use this session here to get db session equals to get sync session. Okay, fine. And mm, mm, mm. Okay, let me just replace this complete thing. I guess it will not work here. Okay. So let me do the session equals to small session equals to um, next dot get session. Okay, fine. Then I'll do the try unexpected indentation. Okay, it will be the try, then the order equals to session dot exec session dot exec select order. select order. Okay, dot where. From SQL model. Select order where order ID equals to order ID dot first. Okay, if not order, return error, order not found. For stage in stages, time dot sleep 10, order status equals to the stage, and then it will go for the session. Okay, fine. This is session, session, and session. Session dot refresh. Refresh will be the order. Okay, and then return. Then finally session dot close. Let me just do the indentation correct. Okay, so everything is fine right now. Okay, let me explain what I'm doing here is I'm just simply creating a delay in the order. I'm just not doing anything. I used this list, the stages list. After every 10 seconds, what I'm doing is taking the data from the DB. I'm updating the data from the list and I'm pushing that data into the DB. It is the part which I'm doing here, this particular for. And everything else here, what you can see, this get sync session and this creating session is just for to the communicating with the database. Okay, so this part is done. So we have this tasks.py, we have this worker.py. Now let's come back here to understand what part is remaining. So we created the synchronous Celery task process. Okay, we set up the Celery app in FastAPI. That's fine. Now create the API to use the task process. Okay. So for that, what we will do, we will come inside the API and we will just create the background status.py. We are not going to touch any other API, so that we are not going to update any other file. That's why I created the background status.py. Okay, so here I have this background status.py, and inside this, as I told you, we can create this particular API as async, as we already created this process order dot delay in the synchronous. So this logic will be fine, and it will match with the fast API requirement. Okay, so for that, what I will do first, I will just use the async here, this async def, and I need to update few more things. Then what I will do here is from core.db get session. Okay, from model import order API router. Okay, I have this. I do not need this get session. Okay, from task, I have this process order, and from the schema, I just use the order create and order response. What is this schema? This schema is something. Okay, let me just put it here. This order create and order response. When you are hitting an API, you want some response in some structured way. So it is something that it is that schema which you get after hitting the request in the response. This is the structure of that response which you are expecting from the backend server. So for when I'm going to use this order create, what I need, I just need the customer name. It is very simple schema. Whenever a customer is creating an order, then I just need the customer name and the item name. And when the order response, in the order response, okay, so when we creating the order, what I will provide, okay, I'm code goat and I'm ordering some laptop. So what I'm going to give my name and the product name. And in the order response, when I'm getting the order response, I'm gonna need the ID, my name, and the particular status at which my order is lying right now. Okay, so I have this all the things present here in the schemas.py, and let's go back here. Where is that background status.py? Inside the background status.py, it is the router. I created the post API with the place order name, and it is the get order status. Okay, and inside the okay, it is the router.post. It will be the router.get at the rate router.get order status from the order ID. Okay, fine. And it can be async as well. Okay, it is the async, and status will be order ID get order status. Okay, let's remove it now. First, let's focus on this place order. So inside this place order, I have this order. It should be with the order create, and this DB. DB can be the async session. Okay, let me call the async session from SQL. Okay, async session. Let's just copy it from here from SQL model extension, basic background status. Okay, so I have this async session. So this DB will be of type async session. Okay, it is the DB of type async session, and it will depend on. Okay, I need to call the depend as well. Depends. It will depends on get session. This get session. Okay, so it will work like this. Session equals to this get session. That's fine. Okay, so let me come back here. Okay, so I have this place order response model will be the order response. Okay, I have the order will be of type order create. That's fine. DB will be of type this. Okay, so I have this new order. Okay, I have this new order equals to order, and the customer name equals to order dot customer name, and item equals to order dot item. Okay, fine. This is the new order. Mhm. I already have this DB. Okay, I do not need these two lines. This DB dot add, and I need to use the await here, await, and then await with the refresh. Okay, so it's very simple. Let me just explain you. Inside this, okay, what I need to do is the return new order, return new order. Fine. So I just created one post API to place the order. Inside, what I'm asking from the user is just the if I see the order response, it should not be the order response. Okay, it is the order response model. Then fine, it should be the order create. Okay, order create. Okay, so inside the order create, I just need the customer name and the item name. That's it. Now what I need is, and I use the process order dot delay. This process order dot delay, if I go to this tasks.py, where is my task.py? So here I have this process order, and it will delay the process the 10 seconds, and it will do the work for me. What I'm asking here, just to give some weight, and we will refresh it and in every 10 seconds to fetch the exact data, like the packaging, shipping, and delivered. Okay, so coming to this, now we need one get API. Okay, so what I will do, router.get order status from the order ID, and it will be the order response. Now, okay, that's fine. Async def get order status, order ID equals to int, db equals to this. Okay, it's taking good. Then the result, okay, I need the result equals to await equals to db execute, uh select order where order id or order id equals to order underscore id. Okay, fine. Order id order equals to result dot first, if not order not found, or return order. Okay, that's it. It's the simplest one. Okay, I need to import the select as well. So from SQL model, I guess I need from SQL model import select. Okay, it's a simple post request and get request type of mechanism in which, first of all, I'm placing the order with the customer name and order name. It will create one record inside the order table. Once it is created the record, then I will just query the get API to fetch the status. Okay, so it is completed. Now the only last part remaining is to up the okay, so we integrated. Okay, we integrated it with the fast API. Okay, we created the API, but we didn't integrate it till. But we didn't integrated it with the fast API till now. Okay, so for that, what we will do, we will go directly to the main.py. Inside the main.py, okay, I have already imported the basic background. Let me just import the what's that name? Background status. Okay, I have this background status right now. And after this, app dot include router, background status, router prefix. Okay, let me just use the delay orders. It is not a logical name. Just for our purpose only, I'm putting this name here. Delay order, and it's the order status. Or let's keep it more order status. Order status. Okay, that's fine. Order status. Okay, it will do the work. We just integrated it with the Fast API as well, Fast API main app as well. So now let's go back here to our bash terminal. Where is our bash terminal? Let's close all the not required files. Okay, here we have run the server UVCon main app reload. Okay, order response base model is not defined. Okay, schemas line number 77.py, line number 77.py. Okay, it should be SQL model. Sometimes you need to correct the AI. AI will fast your work. Sometimes it just auto populate whatever you are thinking, but you have to be careful what you are looking and what you are just pushing enter, or what you are just pushing the tab button into it. Okay, so let's go back to the UVCon and cannot import order from the model. Uh, Models, okay. From where? Background status.py. Okay, let's go to background status.py, and here I have this equal model from models dot model, from model dot models import order. Okay, we have this correct right now. Let's see for any other thing. Okay, attempted retrieve from dot worker import Celery app. Okay, let's go to the task.py from worker in place of dot worker from worker worker. Okay, let me check it again whether it worked or not. No module name Celery. Okay, so we will install it. Pip install Celery Redis. Task.py line number 5 from model.models import order. Okay, now let's check it again. No module name schema. Background status line number 5. Background status line number 5 from schemas. From schemas. Okay, now I guess it should work. Let's check it again. Okay, Now we just resolved all the error. Our application is running. Okay, so now we're gonna need the Celery and Redis services so that we can integrate those services to our Fast API application for which we developed the code already, and we can directly test like what is happening there. To do that, we are gonna need these services independently, which are not the part of our Fast API application. So as I'm working on the Windows operating system, so for the Windows operating system, I'm using the docker.desktop. This docker.desktop will help me to communicate with the Docker container, and it will also help me to run the Docker container so easily without using any command line tool. Okay, so it is very good for the Docker, but if you are working on a Linux-based operating system, then it will be very easy for you to just operate it with the command line tool. Okay, so here what I did is I have just pulled the images of Redis and Celery from the Docker Hub. So if I see this Redis is the image which is like from 2 months ago, and this Celery is the image which is from 8 years ago. So I'm not going to use this Celery image, but I will use this Redis image. And to use this Redis image, what I gonna need is I just need to go here to the run. I will go to the optional setting, and into the host port, I will just use the same 6379 as the port 6379. So whatever the so whatever the services which is going to run inside the Redis server container, which is exposed to 6379, will be mapped to the Windows Server 6379. So what I'm going to do, I will just going to run it. But there is a one concept of networking. Okay, so before that, okay, right now I can see it is ready to accept the connection TCP. So my Redis host is ready to accept the communication from my Fast API application. But we need to understand one concept before moving forward with the Celery. So for that, what I will do, I'm just going to give you some very small basic detail about the, okay, let me clear it. It is not like this. Okay, let's not clear it. Okay, okay, I've already cleared it. Then I will explain you again. Okay, okay, it's a blank right now. Fine. So for the networking part, we need to understand one thing. As I'm working in a Windows application, it is a Windows OS, sorry. I'm working in a Windows OS. So this Windows OS have its own network. That is fine. Every system have its own network. And in this own network, I'm running this Fast API application locally. Okay. So I'm running this Fast API application locally uh, without any other uh, third party tool. Fine. So this Fast API application, which is running locally, we can access it to the local host or 127.0.0.1 colon 8000 port. Okay. It is understandable. That is fine. But in a same Windows OS, I'm running this Docker. Using this Docker, I'm creating the containers. Okay. So just now I created the container Redis. This particular Redis is a server. It is a server which is running in a container. Okay. It is very clear. This particular Redis, which is running inside a container, if I see, if I'm inside the Redis container, this local host will refer to the Redis only. It will not refer to this Windows. No, it will not. This local host will not refer to this Windows OS. This local host will refer to the Redis. But in our code, what we did is, if I go back, okay, let me just hide it. Fine. If I go back to my code and go back to the worker.py, here I provided the address of broker and backend as a local host. So what my Fast API application will think that some service is running inside the Windows network, which will be accessible at 6379 port. But what is happening is I created the Docker container, but that Docker container is not running inside my Windows server. That particular Docker have its own network. So how I'm going to connect with that particular Redis server, which is running inside the Docker? So to do that, our Windows system have very good thing. So what I gonna need is I just need to put here the host dot docker dot internal. Okay. If you are running inside the Linux server, there is no need to update this local host. You can directly use this local host because inside the Linux server, that particular Docker comes as a utility tool of its own. There is for this Linux, this Docker is not a third-party tool. You can understand it like that way. So when there, if you are trying to run it, then local host will work fine. But here you need to use the host.docker.internal. It's for the Windows server. Okay, fine. So, and even we are not going to proceed with the host.docker.internal in a future purpose, and we should not. We need to create a service name, and to do that, we need to use the Docker Compose. But here we are trying to implement it in a very simple way. So that's why I am just creating the service independently. We are not merging all the things, but when we are going to deploy this project into our server, then we will merge all the thing into the Docker Compose file. We will take care of everything like our Postgres SQL database, our all the dependencies, this Celery, this Redis, our requirement.txt, whatever the requirements are there, we are going to merge everything into this Docker Compose single file, and then we are going to deploy it. But for here, what we are going to do is we are just going to implement all the service one by one. So here I have this host.docker.internal. This thing will tell this fast API application, which is running locally, that this particular service is running at the Docker part. eh, That this host, this Windows host, have this Docker utility, and this Docker utility have some internal container which is exposed at the port of 6379 of this Docker network. Okay, so in this way, we are going to communicate with the Docker server, sorry, Redis server, which is hosted inside the Docker. Okay, so I'm going to update these two addresses for the broker and backend. Broker is what? Broker is that it is the part where this Celery will push the task inside the Redis queue, and this backend is that when the Celery is done with the task, then it will send back the response to the backend. So these are these two ports, sorry, these two services which we are using here. Okay, so we are clear with it. Let's go back to our where is this Docker desktop? Okay, so here I have this one running container which is of Redis server. It is fine, and we did the changes as well. Okay, so now it's time for the Celery. But before going to do that, there is one more change we need to do. And what is that? Let's go back to our code. So if I go to this task.py, this task.py, we created this particular method as a synchronous method. It is not an async method. It is a synchronous method. So because we didn't use any async here, and it is a requirement to here we implemented this process order as synchronous method, and it was a requirement to create a method because it is going to the background task. It is a background job, and this background job will work in a synchronous way. And to do that, this particular method, which will be called inside the Celery worker, this method should be synchronous. Okay, so to develop this method as synchronous method, we didn't use the async keyword before the def. But there is one error in it. And what is that? The session which we are using, not session. If I go here, it says session, sorry, engine. Okay. So the session which is using the engine, this engine is using the setting setting from database URL. Let's go back to our database URL. So here, what the syntax we created? We created the, okay, we are using the database, this PostgreSQL. Then we are using the asynchronous database driver. For a method which is synchronous, we should not use the asynchronous database driver. We need to use the synchronous database driver. Because if we are going to use the asynchronous database driver, then it will block your communication. And it will only end up when this timeout is happening, when this timeout is completed. Sorry, not happening, when this timeout is completed. So to do that, what we will do, we will come here and we will create one more database URL, database synchronous URL, sync URL. Okay, fine. This is it. So this database synchronous URL will use the, okay, so I need to use the psycobg2, psycobg2. Okay. Hmm. uh, hmm. So this psycobg2 is a database driver which will work synchronously. Am I using this? Am I using the wrong? Okay. Am I using the wrong keyword? Let me go to the requirement.txt, psycobg2. Okay, let me get back here inside the config.py, psycobg2. Okay, sorry, I was using the wrong keyword. So I need to use this psycobg2 library of this Python, and it will work as a synchronous database driver between my FastAPI application and this database. So the synchronous method will use the synchronous database calling. Okay, so I have this database synchronous URL, and I will go back to my tasks.py, and in place of this database URL, I will update it as a database sync URL, the synchronous URL. Okay, so we rectified one more thing, which is the database connection for our process order. And the remaining thing will be the same. Okay, fine. I have this. I have this. I just updated my worker, which is with the host.docker.internal. I have this task.py, which is now communicating with the synchronous setting. Okay, I have these two things. Now let's come to the Celery part. For the Celery part, there are lots of things we need to configure inside the Celery container. And to do that, we need to create one image, one that one image which will use all those functionality which we want to deploy inside the Celery container. So to do that, I created the Docker file. I will just simply explain it, all the parts from it. And what it will do, first of all, it is taking the from Python 3.10. So it created a empty container. Inside this empty container, there is this image of Python colon 3.10 hyphen slim. So as our complete framework is developed on the Python language, and our logic, which is going to be worked on the request which user is going to send inside the background task, will be worked on the Python 2. So this particular Python should be present inside my Docker container. And to do that, we use the Python 3.10 hyphen slim. It is the minimal, uh, it is the Python setting with the minimal uh, dependencies. Okay, so I have one this Python 3.10. Then after you will see these two env. It is not mandatory. You can skip it if you want, but I will recommend you to use it because with these two settings, your container will use the Python in very optimal way. It will not going to create so many PyCache file. There will be less cache file. There will be less garbage inside your container, and this is what we want. So you can note down it, or you can simply copy it when I'm going to upload this particular project into the Git, which is available to everyone. And you can simply clone it, download it, whatever you want to do, you can do it. Okay, then what we are doing? Then we are creating one working directory for our Celery worker, Celery container. So I use this user source app. Okay, that's fine. You can use anything. You can create your own working directory and it will create. Then fine. After it, as my Celery worker is going to work on this Python logic. This Python logic is using so many Python libraries, and those all libraries are already present inside the requirement.txt. So this requirement.txt, I'm copying it inside my container, and then I'm just simply installing these all requirements as the pip install. Okay, so this part is clear too. So right now what we have, like we have one Python infrastructure inside my Docker container. Now it's a crucial part where it all will work. We are just copying the complete our project inside this container. Okay, so this particular dot, as this Docker file is present inside the parent folder, this fast API e-commerce, this particular dot will copy these complete files inside the Docker containers directory. Okay, so this part is also clear. Now let's come to the last part, which is very crucial, which you need to understand, and which you should uh, which you should see it logically. So as in my requirement.txt, let me open it, this requirement.txt. So I have this Celery as a Python library. So once when you install this, where is the Docker file? Did I close it? Okay. So once when you install this Celery inside your pip network or Python infrastructure, then it will provide you a utility called Celery. So you can directly run the Celery command. Then it comes with the -a worker.celery app. So you created this worker.py, and you are calling this particular app. Okay, that is also fine. Let's go back to the Docker file. Here we are using the worker. From where this worker came? This worker came from here. So it is the Celery app name. Whatever the name you are going to provide, even you can provide anything. It is not required to use worker only. You can provide your name, you can provide anything, but it should be logical. So whatever the name you are going to provide here, you should follow the same after this Celery app, that I need to use this particular app. Now, my core logic, which I want this Celery worker to be worked with, is present inside the tasks. Let me go to the task. So this process order, I want to execute it from my Celery worker. So let me go back to Docker file. So I have provided this path that please import the tasks which is present inside my directory, which I just copied. So this Celery worker will import this task, and it will know that, okay, this particular method, whenever it will be called, I need to execute it. Okay, that is also good. So let's go back to this log level info. So whatever is happening at the backend, I want the trace of it. I want the logs of it. So that's why I just enable the log level as info. If you put it as error, then only when error will come, that only error you will see, but all the other information you will not be able to see. That's why I'm using the info. Okay, so I have this Docker file. What I need to do, I need to create the image. And to create the image, I just use the WSL, this Windows subsystem for Linux. I enabled it in my Windows software, this Windows operating system. And then after restarting the system, it just let me install the whatever the version of Linux operating system in this Windows uh, of my life. So I just install the Ubuntu 22, and using this Ubuntu 22, whenever I'm going to click it, it will open a terminal for me. And using this mount path, as I'm working in the Windows, so your C drive, your E drive or D drive, whatever the drive is present inside your My Computer folder, you will find it inside the mount/DEC, wherever you are working or wherever your project is present. So this my fast API complete project was present inside this path. Like after inside the D drive, it was the YouTube code fast API part 11. So I just use the CD to go inside of this path. Okay. Now I need to create the image, and then I will run this image, and then I will run my code. Sorry, test my code. Okay. This particular fast API server is already running. So let me just check the UVCon if anything is not good. Could not pass SQL Alchemy URL for given URL string. Okay. For given URL string. For given URL string. Why? Okay, let me just close it, stopping the process. Let me reload the app. started reloader. Okay, could not parse SQL alchemy URL. So it should be with the task.py settings.database sync URL. Okay, let me go back to the config.py. Here I have this database sync URL. Let me just save it and okay, could not parse SQL alchemy URL for given URL string. Why? So from where it got started, main.py line number 3, main.py line number 3. Okay, background status. Am I using somewhere else which I'm not updating? Okay, from SQL model, this, async dependency, async IO. Okay, fine. Code.db get session. I guess this is all fine. Okay, my bad. I didn't see the exact syntax, so I need to use the plus sign in place of colon because I've already used the colon. I should use colon here. Okay, so now it should work. Okay, let me go back to the UVCon and it should run without any error. Okay, so now my application is startup completed. So here I have all the things and I'm going back here. It is the WSL again, which I just described earlier. So what I'm gonna do is I'm just going to build one image, this Docker build -t Celery worker, and with the dot, I'm saying to this command line that my Docker file is present inside this directory. Where is this directory? This directory is there in the FastAPI e-commerce. There we have this Docker file. Okay, so I have provided all the things. All I need to do is just to click enter. So it will create the image for me. And this Docker desktop is really good and it is integrated with the Windows operating system. So it will detect it. You can directly run this Docker, this Celery container, this custom container from that uh, Docker desktop. Okay, so it created the image. Now let's go to the Docker desktop. And here I should have this Celery worker. So I have Celery worker right now, and it is created 26 seconds ago. What I need to do, I just need to run it because I just did all the things earlier. So let's run it, and it should create the communication with the Redis host, and it should show that log that it is connected with the Redis, and we can start our execution. So let it start, and then we will do the work. Okay, so it started, and let me check the logs. Okay, it is starting, connected to the Redis host.docker.internal 6379, and Celery is ready. So this particular container is ready to take the load from the user. Okay, so I have all the things. Now it's time to test. Okay, so let's test it. So here I have this post request to do and to one and just get the API first, and then we will run the complete load. So I have this local host. Why it is too slow? Okay, so I have this local host colon 8000 slash docs. Okay, as my fast API is providing me this documentation for whatever the API I have created. So I have this order status in which I created the post API and get API. Inside the code, let me show you again. So I have this background status. This background status have this place order and this get order with the post and get. Okay. So first of all, we will create the order and we will check the order status, the logic which we created. Like first, it should show the packaging, then it should show the shipping, and it should show the delivered with the time interval of 10 seconds. Okay, so this is our complete task. Let's go back here, and here I have the post request which will be executed this API v1 order status and place order. So I will come here inside my where is the postman? Okay, here I have the postman. So I created the URL already, and I will update the customer name. So let's say the customer is Alice. and Alice is purchasing from your website, let's say AI soft, yeah, software which you just created. So let me send it. Okay, so it created the order and there will be one entry inside your database and which have the ID of 9. Now what we need to do is we need to search for the ID 9, like what is the current status. It is a particular task which you just pushed into the background. Okay, so currently the order is placed. Let's wait for a few seconds. It should update it to, where is the code? It should be updated to packaging. So let's go and it should come with the packaging. Okay, we need to check the logs here. Okay, so we are getting some connection refuse. FISO connection refuse port 5432 fail with this psycop G2 connection to the server at localhost. Okay, SQL. Okay, my bad. I just gave you the explanation, but I just forgot to update the local host for the database sync URL, as this particular database sync URL is going to used inside the Celery worker. So the particular URL which we configured inside the worker.py, we are going to copy this host.docker.internal and we are going to this localhost and then we will save it. Okay, so now I guess we just completed the all the puzzle and it should run right now. So what we are going to do, we are going to post some another request because that particular already just got timed out with the some error. So right now I will put the max here and max gonna sell the shoe. Okay, so Max is going to order some shoe from your website and let me hit the post request. So it created one record. It have this 10 and now let's go to the get. Inside the get, I have this 10. Let me hit the send. So it is order is placed right now. Okay. Let's first check the Celery whether it is creating any error or not right now. Oh, again, I need to again create this image because this image is already running with that old code. So that will also not work. So I need to stop this one. Okay, fine. Just delete it. I've already did the changes there. So I need to come here and did the Docker build again. I'm going to use the same image name so that will not, so that we will not be get confused with it. It should not take much time because all the layers are already existing there. Okay, so it created the image. Let's go back here. Let's check for the images, Celery worker, which is created 15 seconds ago. Okay, we are going to run it again. Fine. So it got created and it executed. Fine. This Celery worker is ready to work. Right now we have all the changes. So let's test with some another record. Okay, we are going to hit the post request. This time we are going to use the, let's say, Nora. Okay, Nora. Nora is good name. Nora, and Nora is going to buy some. Nora is going to buy some book. Okay, Nora want to buy some books, so she is going to hit the post request to your application. Now Nora's order created the ID of 11. Let me go and check the get request. Okay, here. Okay, fine. 11 and should be packaging. Okay, I got this status of packaging. Now we need to wait for some few seconds and then it should be updated to something else. Let me check inside the database what is present inside here. So here we have this shipping. Okay, so it updated to shipping and it updated to delivered. Okay, if I go and query it again, so right now it is at the delivered and we have the delivered status here as well. So did you see that our API executed successfully? It pushed the job at the background to the Celery worker, and it freed the resources to the user to use it again. And at the back end, something is working for it. It is doing the complex work for it. It is updating the status at the database. And from your fetch API, you can directly fetch that status and show it to the user that, okay, it progressed this much, 10%, 20%, 30%. So that user will also get some free time to, okay, right now this particular thing is working for me. Let me create one more request. So this is it. This is all which you need to know about the background job. The part where we are using the container, it is good. It might be create some issue for the one who is using this Docker inside the Linux server. The one for the Windows, I've already explained it. But don't worry, we are not going to get any confusion when we are going to deploy it on the Linux server, because all the applications are deployed on the Linux server. No one is using the Windows OS at the deployment. So this is it. And I hope that I explained you all the things which are required to complete this part, this background process. And if you get any issue or if you have any query, just please let me know. I will try to resolve it, and I will update the code as well if it is required. And thank you. Thank you for watching. And if you like it, then please and subscribe my channel. Please like this video, share it to your friends, and hope you're all doing good. Thank you.